Hi everybody, welcome. We're going to be talking today about representing data with histograms. So I wanted to give you these notes just that you can go through and copy down on your own so that you can finish out Edgenuity for this week. So the first thing we want to talk about is, well, okay, what is a histogram? It sounds fancy, and it looks like a bar graph for the most part. But there are a few differences. So we just want to compare side by side here a bar graph with a histogram and see what the differences are. Okay. So the first thing you'll notice is that there's gaps in a bar graph, and there are no gaps in a histogram. A bar graph doesn't have to have gaps, but it can. A histogram does not. So all of the bars that you see will be sort of pushed together. But that seems like a silly reason to have two different names for them, so there's got to be more to it. And there is. The other reason, and the main reason why we have different names for them, is because bar graphs don't have to do with numbers on the x-axis. These are always categories. So on a bar graph, we would say here, like, okay, USA, that looks like, $190. India, that looks like about $210. The United Kingdom, that looks like about $400. These are categories. In other words, they have names. So that will always be the case on a bar graph. On a histogram, however, we're talking about on the x-axis will be number ranges. So it's a little bit different in that sense. So if we're trying to figure out what this histogram is saying, looking here, I see that this is about 20 or 21. But what does that mean? Well, it's not saying that there were 21 scores of 100, and it's also not saying there were 21 scores of 150. This is a number range, and a range is something between two numbers. So what this first bar tells me, this first column, it tells me that there were 21 scores between a 100 and a 150. So in between those, in that number range, there was this many. Which makes sense then that the next one has to bump right next to it with no gaps, because the next one is scores between 150 and 200. And the next one is the scores, so these would be the scores between 200 and 250. These would be the scores between 250 and 300. These would be the scores between 300 and 350. So each of these is a range of scores that's evenly split up. So there are 50 points that you could get here, 50 points here, and that's the difference. So if it's number ranges down here, then that makes it a histogram and not a bar graph. Okay. So hopefully when we get into concrete examples, reading them is going to get a little bit easier here. Let's try and talk a little bit more in general about the shape. So there's some different shapes that you can see on a histogram. And so these are the three main shapes you can see, A, B, and C. So you can see here, it seems like if these were, imagine test scores. This looks like this class in general performed lower. This class looks like they in general performed higher. And this class looks like, they performed right in the middle here. And so this one, C, is actually what we would say is like kind of like the benchmark of how we judge the shape of any other histogram. So for as far as the names of what we would call these things, C here is what we would call symmetric. That's that word right up here, symmetric. And so it has symmetry. And if you have college professors someday, they might grade on a symmetric curve or a bell curve, meaning that when they give an assignment, they're going to grade it such that most students fall right here in the middle, getting a C. Then there's less students falling here getting B's, and there's just as many students that they're going to give D's to. And then there's going to be even fewer students that get A's, and there's going to be the same number of students that give F's to. Whether you think that's fair or not is up to interpretation, but there's some people that say, this is the bell curve, this is the way it's going to go. There's going to be people in the middle, most people are going to be average compared to the class, and then there's going to be some high flyers and just as many low flyers, if you will. So this would be the symmetric histogram, and it's how we judge the shape of all the others. Okay. So with that being said, I'm going to look for the differences between, say, like A and C. Well, here I notice I've got the same general shape here. I've got like a high one and then two that are kind of symmetrical by it. But I have this over here that's different. So this right here is different in part A. In other words, I sort of took, there should be more stuff over here, but it wasn't. It kind of got moved over to this side. And so we call this sort of longer line, a line that's longer than it should be, we call that a tail. So I would say histogram A has a tail because, this right here should have been over here if it was symmetric. And so I say it has a tail over there. Same thing goes for graph B. I'm saying, well, it should have more stuff here, but it doesn't. It's sort of pushed over this way. And so I would call this a tail as well. And so we call that a tail. And so the way that we talk about these things is we use the word skewed. Skewed just means like you're moved a little bit off. So if I like my keyboard lined up just right and it's turned a little bit to the right, I might say, my keyboard's a little skewed. It's a skew, if you will. Different ways you could say the same thing. So when we look at these tails, what we call these graphs is based on where that tail is. So A here, the tail is on the right side of the big one. So you look at the big one first, and then you say, okay, is the tail to the right of that or to the left of that? And I say, in this case, the tail is to the right. There's more stuff popping up on the right than what should be in a symmetric graph. And so for A, we would call this skewed right. Skewed right. Because the tail is on the right side of the highest frequency. There's more stuff over here than there should be. Same thing for option B here. I see the tail, and I look at, okay, where's the biggest one at? And I say, okay, compared to the largest, there's more stuff on the left than there should be. There should be things over here if it was going to be symmetric. So for option B, it's just the opposite. I would call that skewed left. And that might be a little confusing at first. That might not be how you would choose to describe it, but that's how it's defined. That's what we're going to stick with as far as talking about it. So this would be skewed right because there's an extra tail on the right. This would be skewed left because there's a tail on the left. So always look for the tail first. That will help point you in the direction of where it is being skewed. Okay. All right, well, let's try and go ahead and read some of these and use some real examples here. So we're going to be reading these histograms first. So here is the histogram we're going to be using for the first 5 questions. So I've got number of people, and I've got age ranges here. So again, we aren't labeling them as like, children, teen, and high school. We have age ranges, 1 to 10, 11 to 20, 21 to 30, 31 to 40. So that's what makes this a histogram, and there's no gaps between. Okay. Cool. All right, so it says first, which age group has the maximum number of people? Well, the number of people is here, so I'm looking for the highest, basically. The highest number was this one. There were 35 people, but that's not which. So be careful you look at your question words. It's not asking how many, 35. It's asking which age group. And so the age group that has the most number of people, that would be 21 to 30. Number 2, if you'd like to pause the video and try these on your own first and see if we match, that's a great idea. But I'm going to just go through them each. Number 2, which age group has the minimum number of people? The opposite of that would be this one here, would be the lowest. And so that is the age group 1 through 10. Again, that answers the question, which age group, not how many. Number 3, what is the frequency in the age group of 11 through 20? Frequency is another word for just how often does it happen. And so looking at 11 to 20, what's the frequency? That is 25. There are 25 people in this histogram that were aged from 11 to 20. Good. Number 4, how many people are there in age group of 0 to 20? Well, I don't see 0 to 20 anywhere on here, but I do see 1 to 10, and I do see 11 to 20. So if I know there are 15 people here, and I know that from 11 to 20, we just did that one, there are 25 people here. Well, then altogether, from 0 to 20, I would just add those two together. 15 plus 25 would be 5 plus 5 is 10. Carry the 1. 2 plus 1, that would be 40 people. Good. And then the final one here, how many people are older than 30? I'm looking for the cutoff of 30. There it is. So that's age 30 right there. So the number of people older than that would be everybody in this category, and so that would be, however many this is, 25. Good. Excellent. And then looking at the skew here, how we would describe the skew, it's almost symmetrical, except if it was symmetrical, I would have one other one over here, like that. That would make it perfectly symmetrical, like that. But since this is not here, technically, even though it's pretty close to symmetrical, I would call this right here a tail. In other words, if I got rid of that, it would be symmetrical. But since it's there, it's a tail, so the tail is on the left, so that means that this graph is skewed left. Okay, good. So hopefully the reading them is getting a little bit better. Go ahead and you can pause the video again, try number 6 through 10, and I'm going to go through them right thereafter. Okay. So number 6, how many students got marks in 26 to 50? So between 26 and 50%, how many students got that? Well, here's that category, 26 to 50. And so I noticed that that is 20 students. Good. And marks is just a more European way of saying grades. How many students got more than 50 marks? Let's see here. Well, let's see. Here's the cutoff for 50. And so we're saying more than that would be all of these students combined from here to here. And so that would be, I need to find out how much is in each category. Well, this one's 70. And this one over here is 50. And so all of those students scored more than a 50%. And so adding those up, well, 50 plus 50 is 100. And there's an extra 20, so that's 120 students. Which marks range has the minimum frequency? So again, frequency is just a fancy word for how often does it happen. Minimum is just the lowest. So the lowest frequency, in other words, the lowest amount received, thankfully was this one. The fewest number of students got it from a 0 to a 25. So which marks range? Remember, the range of numbers is on the bottom. That's not how many students. Good. Number 9, how many students got 50 or lesser marks? So again, same idea. I know that 10 students fell here. So we just read that one. And then here for this one, I'm reading and saying, okay, 20 students fell in there. And so altogether, the ones who got 50 or fewer would be these two together. 10 plus 20 is 30 students. Good. And then the last one here, how many students got marks between 51 and 75? And so that one we've already done. Between 51 and 75 is right here. That would be the 70 students we read. Perfect. Good. And then this one has a little bit clearer of a tail. This one is definitely not symmetric. It's not the same. I don't have, this and something like that. It's not symmetrical. There's definitely a tail here. I can see that the tail falls right here. And so since that tail falls there, I would call this also skewed to the left. Okay. So give that a try, see what you can do, and let us know if you have any questions.